Welcome to the debate. For centuries, the practice of medicine has been, it's been fundamentally reactionary. You wait for the smoke, and then you try to put out the fire.
Right.
A patient presents with chest pain, you look for the arterial occlusion. They show signs of jaundice, you check the liver. It is incredibly linear, and frankly, it means we are almost always arriving late to the emergency.
Exactly. The symptoms we treat are really just the alarm bells. And by the time they ring loud enough for a clinician to actually hear them, the house is already burning. The underlying biological damage of chronic conditions, whether that is metabolic syndrome or joint degradation, it's been compounding for years in the dark.
Which is exactly why the recent epidemiological data and the clinical trials surrounding artificial intelligence in healthcare are so fascinating. We are looking at a fundamentally different architecture for global health.
A proactive one.
Yes. The rapid global integration of AI, specifically its role in predicting metabolic diseases, revolutionizing medical imaging, and tracking chronic inflammation, is basically an attempt to install a global smoke detector, one that triggers years before the fire ever starts.
Or, depending on how that detector is built and who is programming it, it could be a system that only detects smoke in very specific types of houses, leaving the rest to just burn to the ground.
And that tension is exactly what we are unpacking today. We are drawing on a comprehensive review of recent global health data, clinical trials, and epidemiological modeling to ask a central question. Does the global deployment of AI in healthcare serve as a democratizing equalizer that bridges critical gaps in medical access? Or does its current trajectory, which is frankly plagued by fragmented data silos, algorithmic bias, and completely opaque models, threaten to amplify existing health disparities and clinical risks?
I am arguing that AI is a transformative, democratic force. It acts as a vital multiplier, bringing expert-level diagnostics and proactive guardianship to resource-scarce environments. And I will be representing the position that the fundamental architecture of these AI systems is structurally compromised. Deploying opaque, biased algorithms across fragmented global infrastructures does not democratize care. It risks exacerbating inequality and introducing dangerous clinical errors at an unprecedented global scale.
Let's start with the sheer mechanical advantage AI brings to the table, because we really have to understand the scale of the problem to understand the solution. For decades, global health has been throttled by a severe diagnostic bottleneck. We have billions of patients and a very finite, highly concentrated number of specialists. AI completely shatters that bottleneck. Take convolutional neural networks, or CNNs, in medical imaging.
But we need to be clear about what those networks are actually doing. It's not magic.
Right. It's not. A human radiologist looks at an ultrasound and sees a blurry grayscale picture. They're relying on years of training to spot a shadow that shouldn't be there. A CNN doesn't see a picture. It sees a massive grid of numbers. It processes those pixels layer by layer, extracting microscopic features like edges and tissue textures through, millions of computational nodes.
Sure.
Because of that mechanism, we are now seeing CNNs detect fatty liver infiltration in ultrasound scans with 95% accuracy.
Wow.
Yeah, that surpasses human radiologists in multiple clinical studies. Or look at Google's DeepMind MedPalm 2.
Ah, the PET-CT model. Exactly. It can analyze a full-body PET-CT scan for metastatic cancer in just 3 seconds, maintaining 94% sensitivity. That is a meticulous slice-by-slice process that typically takes a human radiologist 15 minutes, but the speed isn't even the most important part. It's the access. How so? We are seeing portable ultrasound devices from Butterfly Network being used in Indian refugee camps to diagnose rheumatic heart disease in children in a matter of seconds. In the Brazilian Amazon, where specialists are practically non-existent, AI is interpreting chest X-rays for tuberculosis on solar-powered tablets. That levels the playing field for the underserved in a way human infrastructure simply never will.
I hear the optimism in that perspective, and the raw computational power is impressive, I'll admit. But we have to ground this in infrastructural reality. Speed does not equal equity, And it certainly does not equal accuracy if the foundational data feeding these models is fundamentally flawed.
Okay, but
You talk about democratizing access, but the systemic vulnerabilities in these algorithms are profound. We have to look at algorithmic bias.
well, every medical tool has a margin of error when first deployed. That's just the nature of medicine.
This isn't just a standard margin of error, though. It is a structural blind spot. A 2024 MIT audit showed that U.S. skin cancer AI models were underperforming by 20% on darker skin tones. Why? Because the images the AI learned from were predominantly of lighter-skinned patients.
Right.
Early U.S. models were consistently over-predicting metabolic risks for minority populations because their baseline for normal was trained on Eurocentric datasets. Furthermore, the rush to deploy these systems completely ignores the hardware realities on the ground.
How so? I mean, the whole point of the tablet deployment in the Amazon is bypassing heavy hardware.
But you're still relying on a technological ecosystem that doesn't exist uniformly. Sub-Saharan Africa has roughly 0.1 MRI machines per million people. The United States has 40 per million.
Yeah.
Taking algorithms that were optimized on Western, high-resource demographics where patients get regular, high-resolution scans and deploying them via low-resolution tablets into resource-scarce environments doesn't level the playing field. It creates a perilous illusion of competence. We are trusting algorithms that haven't been stress-tested for the specific biological and technological environments they are actually diagnosing in.
We aren't just taking Western algorithms and blindly pasting them into rural clinics, though. The reason AI is so potent is precisely because it identifies nonlinear patterns in the data that human clinicians simply miss, regardless of the environment. Let's look at its predictive power, specifically with type 2 diabetes.
Okay.
Google's DeepMind can now predict type 2 diabetes up to 3 years in advance simply by analyzing retinal fundus images.
Just basic eye scans?
Exactly, basic eye scans that can easily be captured in remote Indian villages or Brazilian favelas using cheap attachable smartphone lenses. The model achieved an area under the curve, or AUC, of 0.91.
That's high.
It is. In plain terms, that means it is correctly identifying 91% of at-risk individuals years before their blood sugar cascades out of control. It sees the microvascular changes in the eye long before systemic symptoms appear.
But seeing a pattern and explaining it are two very different things in medicine.
Let me give you one more example before we get into the explainability part. Stanford's AMI is using time series forecasting to analyze routine C-reactive protein, or CRP, and erythrocyte sedimentation rate, ESR, lab results. Usually, a doctor looks at those markers to see if you have an active infection or inflammation right now.
Right, it's a snapshot.
Yes, but the AI looks at the velocity of those markers over time. By tracking that trajectory, it predicts rheumatoid arthritis joint erosions 6 months ahead of time with 89% accuracy. It is like having a master chess player looking at the board. The AI is seeing 10 moves ahead of the disease. Demanding perfect transparency into exactly how the algorithm weights every single pixel or data point, the so-called black box problem, should not be a reason to delay deploying this kind of life-saving foresight.
I'm sorry, but I just don't buy that. Let me tell you why. You use the analogy of a master chess player, but clinical medicine is not a game of chess. If the grandmaster tells you to sacrifice your queen, you need to know exactly why before you make the move.
But
The clinical danger of opacity is not a theoretical academic debate. It is a massive real-world liability. Put yourself in the shoes of an exhausted clinician in rural Nigeria. They are staring at a tablet that just flagged a patient for a severe intervention, but it offers zero clinical rationale. They are already balking at these systems because blindly trusting a black box gets people hurt.
But they aren't blindly trusting it. It's meant to be a diagnostic aid.
When the software is presented as an expert system, human deferral happens. It's well documented. Look at the devastating 2025 false positive scandal involving the Korean sepsis AI.
I remember that.
The algorithm aggressively flagged patients for sepsis, which is a lethal blood infection, but it was doing so based on incredibly noisy, routine biomarker fluctuations. It led to massive overtreatment, unnecessary administration of strong antibiotics, and severe resource misallocation.
And the clinicians couldn't stop it initially because they couldn't see the algorithmic logic.
Which is exactly why explainability tools are being rapidly integrated into the software. It's an evolving tech.
But they aren't ubiquitous yet. Without robust explainability tools like GradCam heat maps, the system is dangerous. For the listeners, a GradCam is essentially a visual overlay. It highlights the exact pixels on a scan in red or yellow to show the doctor, hey, I am flagging this pancreatic lesion because of this specific cluster of cells right here. Without that, the black box isn't a master chess player. It is an unverified oracle.
I think it's unfair to treat the black box as a permanent fatal flaw rather than what it actually is, which is a transitional engineering challenge. GradCam and similar tools are rapidly becoming the standard. But your point about trust naturally forces us to look at the input. If we want to trust the output, we have to trust the data itself. And the foundational biases you mentioned earlier, developers are aggressively fixing those through federated learning.
Federated learning sounds great in a white paper, but explain exactly how that resolves the underlying data scarcity in the Global South. How does a fancy learning protocol create data that simply isn't there?
It doesn't create data, it unlocks it securely. Think of federated learning like sending a master chef to a dozen different local kitchens around the world. The chef wants to learn everyone's secret recipes, but for privacy reasons, he is not allowed to take any actual ingredients or written recipes out of the kitchen.
Okay.
So he cooks with them, learns the techniques, and only brings back the knowledge in his head. In AI, the algorithm travels to the decentralized global datasets. It learns from the local patient data, updates its mathematical weights, and only brings back those insights to the central model. No sensitive patient data ever moves or is shared.
So it bypasses the privacy bottleneck.
Completely. Right now, the Pan-UK Biobank and the US All of Us program are federating with Singapore's SG100K and Brazil's 100,000 Genomas project. We are talking about training a single AI architecture on 1.5 million incredibly diverse genomes. Because of this mechanism, we are finally generating fair, accurate outcomes for highly specific phenotypes.
Do you have a clinical example of that working? Because theoretical genomes are one thing.
Absolutely. Look at the South Asian thin fat profile. Older Western-trained models completely miss this. These are individuals with a relatively low body mass index, so they look thin, but they have a dangerously high concentration of visceral fat around their organs.
Right, putting them at massive risk for metabolic syndrome.
Exactly. Federated learning identified that distinct genetic and phenotypic pattern by analyzing the diverse data locally in Singapore and India. The AI is mapping the true complexity of human genetics across borders while completely respecting local privacy laws.
That is a clever mechanism, I will admit. But have you considered that these federated networks are essentially reactive patches on a fundamentally fractured global system? You mentioned federated learning as a silver bullet for privacy, but it doesn't solve the issue of deeply entrenched data silos.
How so?
Well, Europe's strict GDPR regulations fundamentally clash with China's unified, centralized health platforms. You have entirely different philosophies of data ownership. That means massive chunks of the global population will never be in the same data set, federated or not.
But as long as the models can access representative samples, they can adjust.
The problem is they often fail to adjust before they are deployed. When we look at nutrition and metabolic health, early US AI models completely underrated the nutritional requirements of rice-heavy Asian diets. Why? Because the baseline training data assumed a Western metabolic response, where high carbohydrates often correlate with different fat profiles than they do in East Asian populations. The algorithm miscalculated the baseline. Furthermore, look at how these models handle severe malnutrition in children.
You're referring to the computer vision trials in sub-Saharan Africa? The kwashiorkor cases?
Yes. AI trained on Western demographics fundamentally struggles to assess edematous kwashiorkor cases. Kwashiorkor is a severe form of protein deficiency, but a hallmark symptom is edema, extreme fluid retention and swelling.
Right.
When the convolutional neural networks evaluated these children via smartphone cameras, the computer vision got confused. The algorithm was looking for emaciated limbs as the primary marker of starvation,
Because the children were swollen with fluid, the AI miscalculated the severity of the malnutrition. We are trying to build a global brain, but the hemispheres are refusing to talk to each other. And the data they do share is structurally biased by the environment it comes from.
I see why you think that, but let me give you a different perspective on how these models mature. The fact that the AI struggled with edematous kwashiorkor initially and is now being corrected through targeted data sets proves the system is iterative. It learns and it self-corrects. We aren't just relying on macro-level genomic data or static algorithms anymore. We are moving toward hyper-personalization at the edge.
What do you mean by at the edge?
Edge AI means the computation is happening directly on your local device, your wearable, your smartphone, rather than sending everything to a massive cloud server. This proves the localized, culturally specific value of these algorithms. Let's talk about clinical nutrition since you brought up the Asian diet miscalculation.
Sure.
Noom's AI coaches are now delivering culturally attuned behavioral nudges in 20 different languages. For a user in Tamil Nadu, India, the AI doesn't suggest a generic Western diet swap. It specifically nudges them to swap chapati for ragi roti because it understands the local glycemic index impact of those specific regional flours. That hyper-local tuning has boosted dietary adherence by 40% in randomized trials.
That is an impressive adherence jump for an app, sure.
It goes deeper than apps. In Australia, the Black Dog Institute is fusing continuous glucose monitoring data with cultural dietary logs in indigenous communities. They're using AI to map how traditional bush tucker, like kangaroo meat and native yams, interacts with the specific gut microbiomes of indigenous populations. The AI isn't enforcing a Western biological standard. It's optimizing local cultural realities in real time to manage glucose spikes.
I come at it from a different way. That level of hyper-personalization sounds incredible, truly. But it assumes a baseline of connectivity that simply does not exist for the people who need this most.
It's expanding, though.
It is great for a user in Sydney or an affluent neighborhood in Tamil Nadu who has a smartphone and a $100 continuous glucose monitor attached to their arm. But we are willfully ignoring a massive accessibility gap. There are 2.6 billion people globally who remain entirely offline.
But technology inherently scales down in cost. That is the trajectory of all computing hardware.
Eventual cost scaling doesn't help the patient dying of metabolic disease today. For the most vulnerable populations, smartphones and continuous glucose monitors are entirely out of reach. So this hyper-personalization you're championing is essentially a luxury medicine tier. And even if we assume the hardware scales down, you have to look at the regulatory mazes governing this software deployment.
The regulatory frameworks are adapting to the speed of the software. It takes time.
They are disjointed and full of loopholes. In the United States, the FDA relies heavily on their 510(k) pathway. Basically, if a developer can argue their new shiny AI tool is substantially equivalent to an older piece of medical software, they can largely bypass running new, rigorous clinical trials.
Right.
That contrasts sharply with India's CDSCO, which is still running very cautious, nascent pilot programs. Because global regulation is fractured, we are seeing a flood of unproven commercial hype slipping through the cracks.
Commercial hype is not the same as clinical AI. You have to separate the two.
But to the patient, the line is blurred. The market is suddenly saturated with AI keto generators and direct-to-consumer inflammation trackers that make wild, unsupported clinical claims. They are bypassing the rigorous randomized controlled trials demanded by the World Health Organization's 2025 guidelines. We are letting algorithmic alchemy disguise itself as precision medicine. And because the regulatory frameworks are totally disjointed, vulnerable patients are the ones acting as beta testers for these algorithms.
I think it is vital we distinguish between commercial diet app hype and genuine validated clinical AI. Yes, a consumer app making keto recommendations is noise, but the rigorous clinical AI is actively democratizing medicine. While there are undeniable infrastructural hurdles and regulatory bottlenecks to solve,
The overarching trajectory is clear. AI is acting as a proactive guardian.
If the infrastructure can hold it.
Exactly. But look at the collaboration happening right now. For the listeners, when we talk about multi-omics data, we are talking about algorithms that can simultaneously look at a patient's genomics, their metabolomics, their protein markers, the entire biological picture. Processing that in fractions of a second allows us to avert massive disease burdens before they manifest physically. And the ecosystem is actively inviting global collaboration to fix the very biases you've raised. Open source platforms like MONAI for medical imaging or Hugging Face hosting metabolic prediction benchmarks mean that coders from Tel Aviv to Tokyo to Nairobi are collectively refining these tools. We are moving from an era of medical scarcity to one of digital abundance, where a patient in a rural clinic can have their ultrasound interpreted with the exact same mathematical precision as a patient sitting at the Mayo Clinic.
And I would summarize by saying that while the raw computational power to process that multi-omics data is undeniably impressive, deploying it over our current global infrastructure is premature. You simply cannot have a digital abundance of diagnostics if the foundation underneath it is fractured. Between the unresolved black box trust issues, the deep-seated algorithmic biases in the training data, and the profound assay variability we see globally.
Assay variability meaning the lab tests themselves?
Exactly. Even basic C-reactive protein chemical reagents differ by manufacturer from country to country. If the raw chemical test in Nigeria looks slightly different to the computer than the test in London, it confuses the AI's baseline. This technology remains incredibly fragile. Deploying an unexplainable, potentially biased tool into a resource-poor environment without a clinical safety net doesn't engineer salvation. It creates a system where errors occur at the speed of light, masking structural health inequalities behind a veneer of objective, infallible computation.
It seems we have reached a fundamental point of convergence on the sheer processing capability of the technology. Neither of us disputes that AI possesses an unparalleled ability to analyze multi-omics data, continuous glucose streams, and complex medical imaging in seconds. The ability to mathematically map the trajectory of a disease before symptoms arise is a profound leap forward in biological science.
Yes, the pattern recognition is historically unprecedented. I do not deny the math. The divergence entirely rests on whether our global regulatory frameworks, our fragmented data infrastructure, and our clinical safety nets are mature enough to actually harness that power safely. You see an equalizer. I see a massive amplifier of existing systemic flaws.
Which speaks to the necessity of intellectual charity and rigorous, continuous validation as we navigate this diagnostic renaissance. There are even deeper technological layers explored in the source material that we haven't even touched upon today, specifically how generative AI is beginning to simulate entire metabolic pathways to predict drug responses before a pill is ever swallowed by a human.
Indeed, the integration of physics-informed neural networks to simulate how an aortic aneurysm might evolve untreated inside a specific patient is another frontier entirely, and one that will require just as much, if not more, intense scrutiny.
We will leave it to the listener to decide if the integration of AI into global health acts as a secure, proactive guardian or a premature deployment of algorithmic alchemy. But think back to that broken medical landscape we discussed at the start. That house quietly filling with smoke while the clinicians remain unaware. The question isn't just whether we can build a better, faster smoke detector. The question is whether we are willing to build it so that it protects every room in every house equally. Thank you for joining us on The Debate.